In this final video, we're going to be writing some code to test out our newly created resident student class. We created the resident student class by extending or inheriting from the superclass student type. And as we inherited from student type, we learned that we only have to declare the differences between the two files. So we only have to include new data fields and new methods that weren't part of the original student data type. At this point, we're going to write a main program that declares objects of both student type and resident student type, and see how that we can use those together in a project. So earlier, we created a basic kind of tester program just to test out a lot of the methods that were part of the original student type, something that let us read some data from user input. Then we bundled that information together into our student object. I called it student1. And then maybe we want to be able to print out the student1 contents so that we can verify that all of that data got added in correctly. So we have that code in our program so far. Let's run it. So far, this program doesn't use any of the resident student data type at all. So as we run the program, let me move this up so we can see. I'll type in some data for a student. Maybe it's Joe Jones, and he has a 3.5 and 60 credits. So you can see that the program allowed us to enter the information for the student and then use the toString method to print out the contents of that object. Now let's add some code to our project so that we can declare a resident student data type. So I'm going to call it student2. And let's call the version of the constructor that takes all of the arguments. So let me just pass in some literal values like Sally Sparkles. She has a 4.0 and 15 credits, and she lives in Virginia Hall. And her room number is 101. Super. So it's calling the non-default constructor, the one that's in our resident student data type. That in turn is going to call the superclass's non-default constructor to initialize first name, last name, GPA, and credits, and then we'll initialize the specialized resident student information with the remaining statements in that non-default constructor. Just to make sure that everything gets initialized correctly, let's print out the contents of student2 after we've initialized it. I'm going to call student2.toString to print that out. Let's run our program to see the behavior. So it's going to ask me to enter the data for student1 again. So that's Joe Jones. He has a 3.5 and 60 credits. It prints his information. Doesn't prompt us for Sally's information because we just use literal values for all of that. But it does print out the contents of that object so that you can see that it has the correct data in it. And so you can see that you can use those two data types effectively in your program. And remember, the benefit to using inheritance was that we didn't have to start from scratch to write the resident student data type. We could recycle a lot of that logic that we had already created and tested for the student data type. Another benefit of inheritance is that you can actually use the more specialized version of a data type, like resident student, anywhere that your program is expecting the superclass. So if we created, for example, an array list to store information about students, we could say, hey, I want my array list to store student types. Call it enrollment. So I've created an array list, and then I could add student1 to that array list. You'd probably expect that because student1 has data type student type, and we said that's the kind of information our array list is expecting. It might surprise you to know that you can also add student2 to the array list because it's expecting a student, and student 2 is just a more specialized version of a student, it's perfectly happy to allow you to add student 2 to our array list as well. Let's add some statements so that we can print out the contents of our list, just so you can see that those 2 data values both got added to our array list collection. So I'm going to make a count controlled loop. I'm going to iterate for each enrollment. Making a count controlled loop to iterate once for each item in my array list. And then inside my loop, I want to print out the enrollment at position I, and then I want to call toString with that, so it prints out the contents of my object. And let's go ahead and run that. Again, it's going to ask me for my data about the student. Create my object for Joe. He's a student. And then it's going to create my resident student, student 2, using my literal values. And then I printed out a blank line and then the contents of my array list. So it printed a blank line, and then here's the contents of my array list. It's the 2 student objects. One is a plain student type, and the other one is a resident student data type. Print both of those, and they're stored together in that array list. The idea that these can be used interchangeably in Java and that it can figure out what the data type of the object is a concept that's called polymorphism. It's something that you'll talk about a lot if you take the object-oriented design course.